my dears. Now here we will tackle even more challenging factoring questions. In my opinion, you should definitely try the questions on your own first, then listen to my explanation afterwards. You can already access clean PDFs of these from our community via the description section. I'm bringing the questions up on the screen for you. I really tried to make the questions challenging. I had all of them written out by artificial intelligence one by one. The questions, it says to factor this. Number 1. This is our number 2. Completely factor it. Here, it also says to factor. Here as well, we are factoring our number 5. This is our question number 6. This is our question number 7. Now, questions number 8, 9, and 10 are similar to each other, but they're not very easy to remember. That's why you need to work through them. Even though questions 8 and 10 are very similar to each other, after solving one, isolating the other, even though it's easy, when I first encountered a question like this, the first time you encounter one of these in any exam, whichever one you get, which method should you use to solve it? I'll explain that. Because number 10 is a bit easier, while number 8 will be a bit harder. This was our question number 8, then our question number 9, and our question number 10. Now, let's start step by step. I'm explaining all of these to you. First, we're on our first question. Now, here's what we need to do. Usually, in these questions, the numbers go in a sequence. The ones here, they either increase or decrease. We need to do something like this. We need to consider the 2 in the middle and the ones at the beginning and end separately. From the multiplication of these x's, isn't it x squared plus x squared 3x 2x 6? So x squared plus 5, x plus 6 comes out. What do we get from multiplying the greens? From the greens, multiplying x plus 1 by x plus 4 gives x squared plus 4x plus another x makes 5x plus 4. I'm writing it here. X squared plus 5x plus 4 minus 24. Now let's go to x squared plus 5x, for example. Let's call it k. We call this k, and this one k as well. We said after multiplying k plus 6 by k plus 4, we'll also subtract 24. Now, when we multiply this, k squared plus 4k plus another 6k makes 10k plus 24 minus 24. Usually, when these 24s cancel out, the number here is given anyway. These cancel out. It could have been something else as well. There could have been a trinomial left here, and it could have been factored as well. K squared plus 10k remains. This also means k times open parenthesis k plus 10 close parenthesis. What we called k was x squared plus 5x. Let's write x squared plus 5x for k, and for this k here, again, x squared plus 5x plus 10. We can't factor this one any further, but we can write this as x times open parenthesis x plus 5 close parenthesis. X times open parenthesis x plus 5 close parenthesis x squared plus 5, x plus 10. This is our answer. I think it was nice. Our second question. This is also a good question. I'm going to suggest something like this. Of course, we can do this. Here, we can factor out x to the power of 4. X plus 1 remains. Here, we can factor out x squared. X plus 1 remains. And here, we already have x plus 1. Then we can factor out x plus 1 as well. But I'm going to suggest something else to you. If we write x minus 1 over x minus 1 in front of this expression, multiplying x minus 1 by this gives x to the power of 6 minus 1. I think I explained how to expand this in the previous document, the one with the difficult questions labeled number 2. X to the power of 6 minus 1, that's the product of these yellow ones. And below, there's also an x minus 1. Now it's easier to factor x to the 6 minus 1. How? We can factor x cubed minus 1 as a difference of squares and also as x cubed plus 1. Below there's x minus 1. Now above we factored x cubed minus 1 as x minus 1 times x squared plus x plus 1 and x cubed plus 1 as x plus 1 times x squared minus x plus 1. And below there's also x minus 1. This cancels with that. And this is the answer. Let me write it one more time. x plus 1, x squared plus x plus 1. Even if this isn't asked on its own, it's a type of question that can easily be part of limits or derivatives. It's a type of question that can be added very easily. That was the second one. This one was important too, in my opinion. And this one was important as well. I'll mark that with a star. I'll probably mark all questions in this document with a star. We're on the third question. This question is also really, really good. There's something very important here. If we can't figure that out, the question won't progress and we'll get stuck. And that's where it stays. Third question. Now let's distribute these first. From the letters A, B, and C, I put whichever comes first alphabetically at the front. So A. I write that one at the front. I recommend you do the same. I don't write A squared B minus A squared C plus B squared C minus B squared A. I don't write it like that. I write AB squared. Of course, the other way is also correct. I don't write plus C squared A, C. I write squared. And minus BC squared. Now, if I look at the ones with A and B here, if I factor out AB, I'm left with A minus B. If I look at the ones with B and C and factor out BC, I'm left with B minus C. And if I look at the ones with A and C plus, I'm writing this at the front, in the common factor of AC, I'm left with C minus A. C minus A. Now let's look at this question. What can we do from here on? So what can we do from here on? I can't factor out anything else as a common factor from inside. What can we do? From here on, we need to make a move, and with that move, be able to continue solving the question. Look, do you know what we're going to do from here on? It's really nice. Question. We're going to do something like this. We're going to take this parenthesis and move it here. And here, we'll add B and subtract B. If you couldn't solve the question and you want to solve it, but you couldn't think of this, now, after the plus B minus B that I added there, try to continue from there. If you ask me, now what do we have here? We have a minus B. In a moment, if there was another A minus B inside this parenthesis, just like the A minus B we have here, and if I distributed this AC over that A minus B as A times C, then with this and that, I could factor out the A minus B, right? All right then, that's good. Let me tidy this up a bit here. Let me make the A minus B more visible here. Here we have AC. To get a minus B here, first I brought this minus A and plus B over here. I left C minus B behind it. And here, when I factor out the minus sign, I'm left with A minus B. See, here is minus A plus B. Here they are. If I multiply this AC by these, it would turn out like this, right? It becomes AC times C minus B. But what do we have here? We have B minus C. All right, I want to have B minus C here as well. Then I'll factor them together. Then let me factor out a minus sign here as well. Let this part also be B minus C. Let's check it. Minus B is right here. Plus C is right here. We've done it correctly. Now then I'm going to distribute this AC, the AC here. I'm multiplying AC by A minus B in parentheses with a minus sign. It becomes minus AC times A minus B. Then I multiply this by those. It becomes minus AC times B minus C. And at the front we have these. Now we'll do the final steps like this. Now I see a minus B with a minus B. And with this I factored out a minus B. What's left? AB minus AC is left. Now there's B minus C, B minus C. I factored out B minus C. What's left? BC minus AC. BC minus AC is left, like this. Now here, there's a minus B. Here, I factor out A. B minus C remains. Here, there's B minus C. Here, I factor out C. B minus A remains. Now here, there's A minus B. Here, there's B minus A. Here, there's B minus C. There's B minus C. The B minus C's are common. But in one, there's A minus B. In the other, there's B minus A. So let's do it like this. Let's write the B minus A here as A minus B. And let's put the other minus here. So we've multiplied this part by -1. We saw one as -1 times -1. I put one -1 here. I distributed the other -1 inside. We're good, right? I think it turned out really well. Now we can factor out the a minus b's and b minus c's. A minus b, b minus c. What's left? A minus c is what is left. A minus c is truly left. Our final answer is a minus b, b minus c, and a minus c. In my opinion, it's a really nice question. Nice. Now we've come to number 4. Now we're going to factor this polynomial. I'm looking. Is there anything I can factor out? Honestly, I can't see anything. So what should we do then? Let's do it like this. Sometimes it's called synthetic division, sometimes Horner's method. First, let's try to find a root. Our constant term at the end is minus 12. We're going to consider all its possible factors, both positive and negative. So, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. We're going to consider all possible factors of the leading coefficient as well, 1 and minus 1. Now, one by one, we'll try these as divisors. We'll check if they're roots, so to speak. If yes, we've found a root. According to that root, we'll either do polynomial division or Horner's method. And the expression with x to the 5th will be reduced to an expression with x to the 4th. Usually, in these types of questions, you try one first. You test it to see if it's a root or not. If it doesn't satisfy the equation, in other words, if plugging in 1 doesn't yield 0, then it's not a root. Then you try negative 1. After that, you try 2. You test it. Do you always try 2? No? You try 2 only if it's one of the factors of the constant term here. If not, you try the next one. But since 2 is here, we'll try 2. If that doesn't work, we'll try negative 2. So this process will go from the smallest to the largest. Now, what happens when we plug in 1? When we plug in 1, let me write this plus or minus 1 right here. When we plug in 1, it's 1 minus, 3 minus, 5 plus, 15 plus, 4 minus 12. What did we get? The sum of this and this makes 15. This cancels that out. 4 plus 1 makes 5. That cancels out, and we get 0. Very nice. So now I can do Horner's division here. I'm writing the coefficients. The coefficient of x to the 5th is 1. The coefficient of x to the 4th, minus 3. The coefficient of x cubed is minus 5. The coefficient of x squared is 15. The coefficient of x to the 1st is 4. And our constant term is minus 12. Since we get 0 when we substitute 1, we're doing it with respect to 1. In different countries, in different curricula, this drawing might be a little different, but this is how it was for us. This is how I learned it, and this is how I do it. So, now we bring down the first coefficient from here. Let me do it like this. We multiply this by 1. 1 times 1 is 1. We write it here. Now we add these two together. Minus 2. We multiply this by that. Minus 2. We wrote it here. We add these together. Minus 7. Now we multiply this by that. Minus 7. We add these together. 8. We multiplied 8 by 1. 8. We add them. 12. We multiplied 12 by 1. 12. We add them. 0. We were expecting to get 0. Now, this part gives us this polynomials yx minus 1, yx minus 1, because when we plug in 1, it becomes 0. 1 is also the root of x minus 1. Therefore, this gives us the quotient polynomial obtained from dividing by x minus 1. This part, 1x to the power of 4 minus 2x cubed, minus 7x squared plus 8x plus 12. Our x minus 1 is in our pocket. We set that aside. Now I'm looking at this. To factor it, I'm struggling again. Does it work when I plug in 1? 1 minus 2 minus, 7 plus, 8 plus, 12. Does it work? It doesn't work. It makes 12. Does it work when I plug in minus 1? 1 plus, 2 minus, 7 minus, 8 plus 12. 12, 14, 15, it works. It works when I plug in minus 1. Then let's do it according to minus 1 now. All right? Let's do it according to minus 1. In fact, let me set this aside. No, I won't set it aside. To the side, let's do it according to minus 1. So, the coefficients here, let me set these aside again. 1 minus 2 minus 7, 8, 12. We were doing it according to minus 1. According to minus 1. We bring down this one as 1 below. We multiply. We add minus 1. Minus 3. We multiply minus 3 by minus 1. We add 3. Minus 4. We multiply minus 4 by minus 1. We add 4. 12. We multiply 12 by minus 1. We add minus 12. Now, what did we divide by here? We did this with minus 1, right? So that means there was also an x plus 1 factor here, minus 1, because that's its root. Now, what is the remainder here? The x terms were to the 4th power, the number of multiples of x cubes. X cubed minus 3x squared minus 4x plus 12. Now, this is easy. If we factor out x squared here, we are left with x minus 3. If we factor out negative 4 here, we are left with x minus 3. Now, if we factor out x minus 3, we get the same result. We're left with x squared minus 4. So what did we have? We had this x. So we had x minus 1, x, and x plus 1, and these are present. X minus 3 and also x squared minus 4. That is x minus 2 and x plus 2. This is our answer. I think it was good that we talked about so many things. Our 5th question, this one isn't difficult. Let's call this u. U squared minus 2, u minus 8. Let's factor this like this. U 4 times 2. This one is minus, this one is plus. We multiplied diagonally and added. Minus 4u plus 2u makes minus 2u. So we take our factors horizontally. Now, u minus 4. U plus 2. U, which we called x squared minus 3x, stood for x squared minus 3x. X squared minus 3x minus 4. And x squared minus 3x plus 2. We can factorize this again. X 4 times 1 minus plus x 2 times 1 minus minus. We multiplied diagonally and added x times 4 plus x times x gave us 3x. We've obtained the middle term. Now we'll write our factors horizontally. Again, here we multiplied diagonally and added. X times 2 plus x times x, we got 3x, the middle term. If we haven't obtained it, we haven't factored correctly. That means we have x plus 4. Horizontally, we have x plus 1. We have x minus 2 and also x minus 1, like this. This is the expression factored. In our 5th question, yes, our 6th question is a bit easier compared to the others. We multiplied this as x squared, and this as 3 times 4 with minus and minus, crossed them and added them up. From here, minus 4x squared. From here, minus 3x squared. We added them and got minus 7x squared. Did we get the middle term? We did. So now we take these horizontally. X squared minus 3 and x squared minus 4. You might say that even if I take it like this instead of horizontally, the same terms come up. But in some questions, the coefficient of this will be different. That's why you'll need to take it this way. That's why it's taken horizontally. The check is done diagonally, but it's taken horizontally. The factors. From here, if we need to factor this as x minus square root of 3, x plus square root of 3. We can also factor x squared minus 4 into x minus 2 and x plus 2. Number 7. Let's call x plus y t here. X plus y equals t. From here, t to the power of 4 minus 5t squared plus 4. We can separate this into t squared minus 4 and t squared minus 1. In other words, it's completely factored as the quantity t minus 2, multiplied by t plus 2, then t minus 1, and finally t plus 1. Are we truly going to leave it just like this without any further simplification or explanation? Of course not, because we made up t ourselves. X plus y minus 2, x plus y plus 2, x plus y minus 1. X plus y plus 1, this is our answer. We had a wonderful time. To our most difficult questions. Before we move on to question number 8, let's try question number 9 first. X plus y plus z. If it's 0, it's telling us to prove it. Now here x plus y equals. If we move this to this side, let's write z. Not by a difference of 2 squares here, of course. Let's expand it using the sum of two cubes. So we expanded x cubed plus y cubed as x plus y times x squared minus xy plus y squared, plus there's z cubed. This is the left side of the equal sign. This is what we're interested in. In the end, we're going to try to arrive at this, and we'll have shown that the left side equals the right side. Now it says that x plus y equals minus z. We're going to write minus z instead of this. If we square both sides here, since we have x squared and y squared here, what do we get? From squaring the first side here, x squared plus 2xy plus y squared equals z squared. So what does x squared plus y squared equal? Z squared equals minus 2xy. So instead of the sum of these two, I'm writing this. Z squared minus 2xy. There's also a minus xy here, minus xy. At the front, there's a minus z factor and also a plus z cubed. Now minus z here as well as z squared minus 3xy plus z cubed. If we distribute the minus z, we get minus z cubed plus 3xyz plus z cubed. This cancels with that, and here's what's left for us. 3xy. We got 3xy on the left side, and there's also 3xy on the right side. So this is equal to that. So it's not very easy for us to memorize this from here, but let's understand it and move on. I don't think memorizing is easy. If the sum of x, y, and z is 0, then x cubed plus y cubed plus z cubed equals 3x equals y. Yes, 8. Now let's get to the question. What should we do here? First, let's factorize this expression. X plus y. We need to do it very carefully so that we don't make any mistakes. X squared minus xy plus y squared plus z cubed minus 3xyz. Now, how many different letters are there here? There are 3 letters in total. Maybe we can simplify things a bit more. For example, let's call x plus y k. Let's call the x plus y here k. This part becomes k. If we square both sides, we get x squared plus 2xy plus y squared equals k squared. So from here, x squared plus y squared equals k squared minus, if we move this to the other side, 2xy. So now, instead of x squared plus y squared, I'll write this. K squared minus 2xy. There's also a minus xy here. So I made it minus 3xy plus z cubed minus 3xyz. We've obtained this. Now let's distribute this to the other side. K cubed minus 3xyk plus z cubed minus 3xyz. Now let's take this and that here and factor them. So we factored k cubed plus z cubed as k plus z times k squared minus kz plus z squared. Minus 3xyzk and minus 3xyz remain. In fact, there's also a minus 3xyz there. Let's factor that out. Let it be minus 3xy times open parenthesis k plus z close parenthesis left. Now let's take the k plus z terms. What remains with k plus z? K squared minus kz plus z squared minus 3, the negative remains. Now, in order to clearly state that this expression is a perfect square of k minus z or k plus z, what exactly do we fundamentally need to consider? The middle term needs to be 2kz, right? Then let's add a plus here. 2kz. Let's add minus 2kz. And let it be like this. From k squared plus 2kz plus z squared, we get the perfect square of k plus z. Minus 2kz and minus kz together make minus 3kz. And there's also a minus 3xy at the end. Here there's also a k plus z. Alright. What can we factor out from here? We can factor out a minus 3 from here. Let's factor out minus 3 from there. It's almost done. It won't turn out to be something perfect, but at least we'll have factored it. K plus z stays at the front. We've opened our parentheses. Here, we have the square of k plus z. And here, inside the minus 3 parentheses, we have kz plus xy. Like this. Now, what we called k was x plus y. If we substitute that in, x plus y plus z times the square of x plus y plus z minus... I just want to focus on this part right here, because I won't be able to fit it over there. In fact, let's just ignore that minus 3 for now. Let's talk about this part. K, as we said, was x plus y. X plus y times z plus xy. What is this? xz plus yz plus xy. In other words, the pairwise products. If there's a minus 3 in front, then it's minus 3xy minus 3xz minus 3yz. Now there's one last thing left. What do we get when we square x plus y plus z? Let me write down the first one first. X plus y plus z. I've removed that arrow now. That arrow actually meant I'm continuing from here. Times, when I open it, x squared plus y squared plus z squared plus. It was 2xy plus 2xz plus 2yz. What else is added to these here? There's minus 3xy, minus 3xz, and minus 3yz. When I add these up, it becomes minus xy, minus xz, minus yz. So, the question is finished, and it has come to this form. X plus y plus z times x squared plus y squared plus z squared minus xy minus yz minus x. It was asking to factorize it, and this was the answer. In my opinion, it's not an easy question. It was the 8th question. Honestly, I think we should start by doing something like this. We're going to take the cube of the trinomial here, right? Let's put parentheses around a plus b. Let's think of this as m. So what do we get from the cube of m plus c? M cubed plus 3m squared c plus 3mc squared plus c cubed. That's what we say. So let's proceed that way. So the cube of the first one, a plus, the cube of b plus 3 times a plus b squared times c plus 3 times a plus b times c squared plus c cubed. And in the back, there's minus a cubed, minus b cubed, and minus c cubed. This cancels out with that. Isn't that right? Those have been simplified. I'm expanding this. A cubed plus 3a squared b plus 3ab squared plus b cubed. This with that. And this cancels out with that too. So these are left 3a squared b plus 3ab squared. What do we do next? Next, if I factor out a plus b times c from the 3 here, will that work? A plus b plus c remains. Isn't that right? I got 3. I got 1a and 1b. I got 1c each. All right. If I remove the 3ab brackets here, I'm left with a plus b. Here too, it's a plus b multiplied by c with 3 in parentheses. There is a multiplied by b plus c. I'm taking the 3's now. I'm getting a plus b's. 3 in parentheses, a plus b. What's left? EU plus. What's left of here? C times a plus b plus c came out. Like this. So what are we going to do here now? You know, we factored this part. This part doesn't really look that nice. What are we going to do here? Let's distribute this first. The 3a plus b at the beginning. Let it stay there. I'm only interested in the part in green. Let's write it like this. I distribute EU plus c. AC plus BC plus C squared. Now let's look here. If we buy this and that, a plus C in parentheses B. If we take this with that, a plus C in parentheses C. So what if we now factor out A plus C? B plus C. Very good. At the beginning it says 3 times A plus B. We found it to be like this inside the green area. A plus C and B plus C. That was our answer. So this is the factored down expression for the exact cube of a plus b plus c minus the cube of a minus the cube of b minus the cube of c. 3 times the sum of pairs. In my opinion, it was actually quite nice. It wasn't easy at all. Honestly, almost this entire page was difficult. Except for 1 or 2 questions, it was tough. I think you should definitely try to solve these questions yourself on a clean sheet of paper. Also, print these out, file them, and review them from time to time. Especially with these difficult questions, especially the ones involving cubes, your reviews should definitely not be just reading through them with your eyes. It's easy to read through the solution with your eyes, but on a clean sheet,